In this video, I will examine some uses of autoclaving, consider how an autoclave works, and look at some methods for determining whether or not the autoclave is sterilizing. An autoclave is a device that uses pressurized steam to sterilize equipment and supplies. Autoclaves are used, for example, in microbiology laboratories, hospitals, medical doctors' offices, dental practices, veterinary clinics, and tattoo and piercing studios. To understand autoclaving, you should be aware of these important concepts. Early microbiologists demonstrated that boiling can kill microbes, and Pasteur proved that uncontaminated sterile media remain sterile. Spontaneous generation doesn't occur. Water at sea level boils at 100 degrees Celsius. But this temperature doesn't kill everything. Some protozoan cysts and bacterial endospores can remain alive. Steam, under pressure, has a higher temperature than that of boiling water. The higher the pressure, the higher the temperature. For example, water boils at 100 degrees Celsius at sea level, but at a pressure of 15 pounds per square inch, the temperature for boiling must rise to 121 degrees Celsius. Steam has another advantage when we need to sterilize something. Steam conducts heat better than air. The result is that 15 minutes of steam at 121 degrees Celsius kills protozoan cysts and bacterial endospores. Now, let's look at an autoclave. Autoclaves are relatively simple. They consist of a chamber surrounded by a steam jacket and having a door that automatically locks when there is pressure in the jacket. This feature gives us the name autoclave. Auto is Latin for self, and clavus is Latin for key, as in a self-locking door. An autoclave also has a pressure gauge to monitor pressure in the chamber, a safety valve to ensure that the pressure doesn't get too high and explode the autoclave, a steam supply, a thermometer, and a drain. Other pipes help control the flow of steam. Now let's consider how an autoclave works. Material to be sterilized is loaded into the chamber. Containers of liquid must be opened so they don't explode. A valve is opened and steam floods the chamber, driving the air, which is heavier than steam, out the drain. The entire chamber fills with steam. Once air is driven out and the pressure has reached 15 pounds per square inch, it takes about 15 minutes to sterilize the objects, depending on their type and volume. Then the steam is evacuated from the chamber through the drain. To check that the autoclave is working and truly sterilizing, we use the sterility indicator, which is autoclaved with the load. Commonly, an operator uses autoclave tape, which is an adhesive tape that changes color when it is exposed to 121 degrees Celsius. Autoclave tape indicates that the autoclave reaches the correct temperature. The operator must verify the right amount of time has elapsed. A more accurate but also more costly sterility indicator is a breakable glass ampule that contains nutrient medium and an indicator dye. The ampule is inside a flexible plastic vial along with some hard-to-kill bacterial endospores. The vial's lid is porous to steam. After autoclaving, an operator squeezes the plastic vial to crush the glass ampule, which releases the nutrient medium into the vial with the endospores. After the vial is incubated for an appropriate time, it is examined. If the color remains the same, in this case red, the endospores didn't metabolize. They were killed, so the load is sterile. If the vial does change color, the endospores germinated and metabolized. The vial is not sterile, so the autoclave load is not sterile either. In summary, an autoclave uses pressurized steam to sterilize materials. Sterility indicators reveal whether or not sterilization is successful.